The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to today's webinar, Increase Your Maintenance Team's Productivity to Lower Equipment Downtime. My name is Paul Custer from Transcat and I'll be your moderator this afternoon. Joining us on the call is Dwayne Smith, Product Specialist from Fluke, who will be leading us through today's webinar. We'll spend the first part of our time today in presentation and then end the call answering your questions. Anytime during the presentation, you can send questions to the question box to the right in your webinar controls. If we happen to run out of time before getting to all the questions, we will follow up offline to the email or phone number you provided at your registration. I also wanted to mention that this webinar is being recorded and will be available for viewing through the Transcat YouTube channel, and we will also forward to the video via email, and in addition, we will make the presentation slides available to you. At this time, I'd like to turn it over to Dwayne, who will lead us through the presentation.
Good afternoon, everybody. Glad to have you with us today. Along with me, I have a sidekick here, Corey Glassman from Fluke, who may interact from time to time in the webinar. But
hi, everyone.
Today, we'd like to talk a little bit about and let you know how you can how wireless test tools can increase productivity, safety, and add convenience to your lifestyle. If you troubleshoot, if you fix or repair things, if you monitor things, wireless tools are certainly a boon to the troubleshooting lifestyle and engineering situations that we face in today's facilities. A little bit about conventional troubleshooting and testing today. Typically, what's been done for a long time now is that troubleshooters or people that are repairing things typically use 1 meter, and you get one reading at a time. Where that presents a problem nowadays is with our complex systems and multiple phasing situations. You can only look at one point at a time, and you have to move from place to place to place, and that makes it a little bit more complicated for troubleshooting. Another issue that everybody faces today is separation. When the distance between two measurement points, or due to an unusual measurement situation, you're separated from where you need to be. Because typically the products that we've used in the past, if you're talking about a scope or a multimeter or a clamp meter or whatever, the test leads and test probes are only 3 to 4 feet long. And in a lot of cases, they don't necessarily always reach from point to point, or if you have to troubleshoot or get into working on ladders or tight spaces, separated controls, where the switch and the circuit you need to test are in different spots.
Yeah, so what I think on a couple things on that, Dwayne, is I've seen where people have to make multiple measurements. They may use more than just 1 meter.
Right. You either need, in a case like that, you either need a helper with another meter, or you need a second meter for yourself so you can do that sort of thing. But the problem that presents there is that sometimes, depending upon where it is, sometimes it's hard to see both displays. So.
And then also on test leads, I mean, I've seen some real sort of kludges out there before where people stretch test leads for a long distance, and wouldn't that present it as sort of an unsafe environment if you're hooked up to high energy?
Well, it would, and that's part of the play with the wireless stuff, the wireless test tools nowadays. Is there's a real impact on the safety for both the user and the measurement situation, where wireless dramatically improves that sort of thing. But back to your comment on the test leads. I mean, if you're talking about measuring, for instance, from one end of a conveyor system to the other, or in the automotive world, if you want to measure from the front end of the trailer to the back, test leads don't do that. And there are companies out there that sell or used to make sell spools of wires that you can make longer test leads. But due to the electrical high energy stuff that we play with nowadays or work on nowadays, it's not a good idea to improvise your own solution for that sort of thing. And then especially The big thing with wireless and safety and the separation is that you can get away from the hazardous point you're measuring. You no longer have to work in front of live electrical panels. You can hook up and then back away from. We'll get into more of that in a few minutes.
One other thing that I've heard in the past is if you use that spool of wire, let's say, if it's a low voltage or a low resistance reading, for instance, you're introducing capacitance and resistance through those leads, aren't you?
Right. There's, wire has a certain resistance or ohms per foot, so, you want to be cognizant about how long that cable is and the measurements you're making. So it really, as far as voltage or current goes, it's not a problem, but if you're talking about low-level resistance measurements, it does have an impact. So basically, again, we'll expand a little bit, 1 meter, one reading at a time. Only spot measurements are possible. It's hard to see if you're looking for cause and effect in a situation where if you're flipping a switch on a circuit or a control and you want to see the output of that control or whatever. In a lot of cases, they're not right next to each other. They're in different locations. So the wireless capabilities, when you have multiple modules working for you, allow you to make that measurement easier. Also, if you're making three-phase voltage or current measurements, you have to make one measurement at a time unless you have a three-phase analyzer, and those things typically start at $3,000 or $4,000 and go up from there. So,
and of course, if it's three-phase, every time you change the measurement location, you have to don all your PPE gear. And
right. The other thing is with conventional tools today, especially around hazardous environments where you're working around moving machinery or robotics or something, conveyor system is another one. When you can't be next to whatever it is you want to see, so the wireless capabilities help alleviate some of those situations. Intermittent occurrences across phases is another thing where multiple modules and multiple measurements help. Again, if you need to see multiple things or look at multiple components in the system at the same time, it's hard to do when you only have one tool to do that. So again, we touched on the separation. That's a biggie, basically because if you need to do two things, be in two places at once, so to speak, you need a partner to do that, or you need two instruments, or you need some sophisticated measurement capability in the tools to be able to accommodate that sort of thing. And if you're by yourself, that basically is a productivity killer. So it's more time consuming, and again, it's not easy to be in two places at once, and that's where we talked about the improvised solutions where you have to make your own test leads to get from point A to point B. You don't want to do that. So
I think what this sort of proves is also everyone's measurement requirements are somewhat unique.
Yeah, absolutely unique and different in many cases. I mean, not everything. If you're talking about making measurements in an electrical panel, there's some similarity there, but the size of the panel may have an impact on what you're doing, the energy level that's present, and just exactly what you're doing all play into that thing. So,
right, and if it's cause and effect, maybe you want to go and flip a switch and then go over to a motor that starts, but maybe there's a delay on the motor.
Right.
You want to check multiple places on that circuit.
Or if you want to do live dead live testing on a branch circuit off of a panel, it's easy to do with the wireless tools because they help solve that separation issue. Basically, safety is a big play with the wireless thing because today and in years past, arc flash is always a concern. Anytime you're making measurements in a energized panel, there's a chance for a accident, a slip, or something where the probe tips get shorted together, phase to phase or phase to ground short happens, and then you have issues. Where the wireless stuff comes into play is that you can install or use a module, use some alligator clips, hook up to the measurement points you want to, and then back away from the panel, energize, or flip your control, or you can get out of the way. The other thing is that you can see in the graphic that the technician in this case has an arc flash hood on his head, and that hood has a very tinted piece of plexiglass in front of them, and it's very difficult to see meter readings in some cases when you've got that hood on. So where the wireless really helps in that case is that you can hook up the modules, you can either power down or powered up, and then you can back away, take your hood off, get out of the flash protection boundary, and then you can see the meter readings while you're not in front of that panel and do whatever you need.
Okay, so in a let's say it's a critical system. Let's say it's a hospital, and you have a critical system, so you can put on your PPE gear, right, and make the connections, but then seal the you're saying modules inside the panel, close the panel up, and then take off the PPE because you're outside that arc flash zone.
The RF communications that are used in the modules today will actually talk for short distances through the electrical panels with the doors closed. So you can technically leave some of this stuff embedded in the panel or installed in the panel for some period of time and then monitor from the outside without even opening the panel door or removing the panel cover.
So even for intermittence, that's great.
Yeah, and absolutely, because in some cases, if you're talking about large three-phase UPS systems in larger facilities, those panel covers can weigh upwards of 80 or 90 pounds, and so it's a two-person job to begin with just to remove and reinstall the panel. So any kind of a convenience you can get out of that sort of situation makes a big difference, because then in some cases you can have a buddy help you pull that panel door to get it off. You can do your install, you can put the panel back on, and then the rest of the work you can do by yourself. So because you're outside of the danger zones. One of the other things that I touched on earlier in the discussion was that conventionally you typically only use 1 meter at a time, and you can only measure 1 point at a time. Well, in today's complicated systems and things like that, in a lot of cases, to speed up the troubleshooting process, it helps to look at multiple things at the same time. So you can actually, what that does is it helps you make a decision faster. When you get more data and see more of what's happening, you can reduce the amount of time it takes you to make your decision to isolate your problem. So
what you're also saying is go back to your three-phase analogy.
Right.
With a single reading multimeter, not only would you have to don the PPE gear every time you make a different connection, but you're getting one reading of one phase.
Right.
And now we have the ability to look at all 3 phases, and they're in the same time domain relationship.
In the case you can use multiple modules in this case with the wireless. I mean, if you've got a family of wireless modules that measure different things, you can use, like in the case of the three-phase example, and conventionally today you would need a 3-phase analyzer or something like that to look at that, and those things, as I indicated before, start at $3,000 or $4,000 and go up. Well, we have a lower cost solution today that allows you to actually look at all 3 phases simultaneously and see the same sort of thing. If you're just looking for instance, typically if you're doing 3-phase stuff, I'll just touch on this, is load checks or load studies. Short-term, I won't call it a load study because the load study is actually a 30-day test, but a short-term load check where you want to see the current fluctuations during the day or a shift or whatever. So
also the Connect system, it's much more than just this, right? I mean, it deals with more than just voltage. It has other capabilities.
Oh, sure. Yeah, we'll get into that a little later in the presentation. But the ability to make multiple measurements and see simultaneous things going on in your system really, really speeds up the troubleshooting process. So here's basically what a conventional wireless test tool system looks like. Basically in the meter, in the center you've got a multimeter, and then you've got some wireless options to the left and right. We've got a flexible current clamp that's a wireless option. We've got a temperature temperature measurement device, and then we've got a hard jaw current clamp, and then a AC voltage module in the bottom. These are all wireless standalone single function measurement tools, and they can all be connected back to the multimeter, or in some cases a PC if you need to look at multiple situations at one time. And in our particular case, the meter can see 3 different readings at any given time simultaneously. And but if you need more than 3, in some cases, if you're on 3-phase and you need 4 or 5, or you're looking at 2 panels on the same circuit, there's a wireless PC adapter that's available that can allow you to look at upwards of 10 tools at once.
And this is a fully functioning digital multimeter.
It's a multimeter just like a lot of our regular multimeters, similar to an 87-179 if people are familiar with Fluke. It's got that kind of functionality in it. So
okay, and so it has the ability to measure resistance, DC voltage. So if I had to measure, let's say, DC voltage, and then wirelessly communicate that with a PC or to another DMM that has the wireless capability, I can do that.
Yes, you can. The modules all have onboard memory, so you can use them for extended measurement logging or monitoring if you want to do such things. So it gives you the ability to, and we'll touch on that later, but it gives the ability for you to hook up a module to a circuit that's giving you a problem and set it up to monitor, and you can walk away and go on to the next job in the facility and let the equipment work for you. So the wireless capability and the multiple measurements is a huge improvement on the troubleshooting conventions of today. We've already touched base on multiple readings. Basically, what you need there is more equipment, more tools. Also, you might need more workers. I think I might have gone the wrong way. So I did. Okay. So sorry about that. Okay. So let's touch a little bit about the benefits of wireless tools. Basically, you can increase your productivity, and you do that actually by the ability of using multiple modules to get multiple measurements simultaneously. So it allows you to speed up your troubleshooting process. Think about, okay, it allows you to isolate your problem faster because you're seeing more faster, so you can make that decision about which direction or where your problem is at. Because if you look at 2 or 3 different situations and you don't see any irregularities, you can move the tools to a different spot, look at a different set of areas to see if you can isolate the trouble faster. And the only way to do that in the past is to have somebody helping you out.
Now you also have minimized writing measurements down, because I've seen electricians work on panels. Let's say they'll make a measurement, they'll write it down on a notebook, make another measurement. So you're saying each one will log and timestamp?
Yes, it's all logged and timestamped. And anybody out there that's done any electrical work or maintenance around facilities will know that typically if you go up to a panel and you do from preventative maintenance from time to time, there's generally a check sheet in that panel door that says what you checked and when was the last time you checked it. So, and the readings that you may have got. So that's old school. It still happens today though. But with the wireless modules and things like that, you install those in the panel and you hit the log button that we have on the product. Now you can record all of that to memory.
How long will those record for?
Basically, it depends on whether you want to use the wireless communication in addition to the logging. If you're using the wireless communication in a panel and you want to stop back from time to time, you can log for 8 hours on a set of batteries. If the radio is turned off and you just want to log over a longer period of time, the way we work today, you get about 3 weeks of logging, and ultimately there's enough memory to hold 65,000 sets of readings in the modules. So,
and the timestamp, that's related to the computer clock?
Yes. Once you download that stuff back to the computer, every set of readings. The other thing that you can do that I'll touch on a little bit is you can set the interval that you want to record at. anything from 1 second to 1 hour and anything in between. So whatever that logging interval is, you can walk away, and when you download that stuff, it's all time-stamped when you get it back on the PC. We'll show you what that looks like a little later in the presentation. Again, the wireless test tools, basically this touches on one of the points. You can see interactions in a system, circuit, or machine. You can look at cause and effect, start and stop, input, output, when you're switching loads on and off. So the ability to do that and be there and see all that happening is increases your productivity, and allows you to see what's going on faster without having a helper there, without having to have somebody else, or without having to have several sets of tools trying to sort that out.
So you can customize it really for whatever your measurements.
Sure, you can. It's pretty expandable, and it's very, very flexible. Again, I just mentioned this. You can being able to see multiple events or multiple situations allows you to isolate problems faster, and when you save time, you save money. Logging data over time, that is a big time saver, because basically, with 1 meter in old school, you had to stand around and watch whatever was going on and hoping something would pop up. With the logging and the memory built into the tools nowadays, you can let the tools work for you by setting it up, hitting the log button, and going off and doing other things while the equipment is working for you, and check back later. You can, again, logging allows you to store readings over time. You can pull it back to a PC. You can pull it into Excel. You can analyze what happened when, and hopefully solve intermittent or unknown power interruptions or system interruptions or whatever it is you're doing. I mean, for instance, say you had a conveyor system that runs throughout the day, and every once in a while it hiccups and actually skips a beat or a bottling line or something. You get some situation that pops up where you're not there when it happens. You don't know what is going on at the time, so you can use the wireless tools like this to put it on where you think you want to start looking first, and then you can start up the process, and if there's any situations that pop up, hopefully the logging devices will capture that and timestamp it for you, so you can equate, when you go back to analyze this, you can equate some sort of event or glitch to something else that's happening in the facility or that's on that panel that may be pulling down the voltage or interrupting that process that's running. So,
yeah, so the other part of that, I guess, is that intermittents don't always behave well. In other words, they can happen at any time.
Right, and they're not always repetitive. So, if you get a repetitive event, intermittent event that happens on a regular basis, that's a lot easier to troubleshoot than something that happens once every day or once every couple of days.
So let's say it's an event or it's an intermittent that occurs on third shift, middle of the night. You may not have your frontline troubleshooters there. They may come on in the morning. So in essence, you can set up the modules, allow them to record, pull down that data in the morning, and then troubleshoot it in the convenience of the control room.
That's absolutely right, Corey, because that's where, if you've got a limited shift or a limited set of people at night, but you're a full-time operation, that's where this the wireless recording and all of this really helps a bunch, because you don't have to have another body there to do this. I mean, these tools are fairly inexpensive, and you can let them work for you and then come back in the morning when you get on shift, download the data, look and see what happened, and then you can kind of analyze what else is going on in the factory at that time or whatever on that circuit to help you sort that out. Here's just a quick snapshot of what a PC application looks like that works with the wireless products that we have. It gives you a screen, and on the left part of that screen you can see a display of how many modules are connected at any given time that are available to view. And the left side actually just tells you what modules are, what function they are, and so on and so forth, and whether they're recording or whether they're live. The lower right screen allows you to actually see live module readings of up to 10 different modules at any given time. And
you can also customize the device ID, right?
right, you can custom name the modules, and also on the view live ratings, you can do real-time graphs on any one of those particular measurements if you want to, and save some of that data. It's a limited set of data you can save, but at least you can do it if you need to.
Now the antenna, you might say, a USB little dongle.
Right, it's just a wireless USB stick is effectively what it is.
Okay, and it plugs into the computer, and it'll give you up to the 10 readings, right?
Right.
Now, let's say you need some more. Can you put on multiple ones?
Yeah, you can use, actually the way our system is set up, you can use 2 PC adapters to look at potentially up to 20 modules or 20 readings.
Okay.
Here's an example of basically the data files that you get out of the modules are CSV files, which is comma separated variables. And that's a standard file format to be pulled into Excel, which is a very common spreadsheet application for doing data analysis. And here's just a snapshot of what a download looks like. It's all time-stamped, it's date-stamped. You get a min, max, and average for every interval reading that you take. And if you have custom-named modules, those are also up there too. And from this point, you can pull this into Excel, and then you can do some graphs or whatever you want to do. And at the top of the sheet, it gives you a snapshot of, okay, where was the lowest and highest reading during that recording time. So there's it gives you a quick snapshot on what's happened, what's going on, so you can go about your business and either identify where the problem was or look elsewhere in the case if you didn't see anything unusual.
Now, what happens if you have multiple computers you want to put the software on? Can you do that?
Sure. The software is available for download on the website, so it's not you can put copies on as many computers.
So there's no real license.
Right.
Okay.
Because the software is only as good as, you got to have a PC adapter for the software. So the software itself doesn't do you any good without the
Okay, so let's make an assumption that I have 2 computers sitting there, both running software, both with 2 individual different USB adapters. Is there a conflict issue there?
No, because the software is set up to, there's a I'm sorry we don't have this running now, but there's a tab. You go up in the software and you go you click on Discover Devices, and it will go out and find each one of those PC adapters separately.
Okay, and so once they're paired, or
yes,
they're mated together, you might say, then it's isolated from being found by anyone else, right?
Right, it will find the 2 PC adapters, and then it goes back and it finds each one of the modules that are associated with each one of those PC adapters.
Okay.
And it does that independently.
So I guess the main thing is if you have multiple modules, multiple either PCs or multimeters, there's not a chance of any type of radio conflict going on where it's going to share information.
No, because once the way the modules work is once they bind, so to speak, or connect to one of the PC adapters, that's the one that they're married to for the whole process. So there's no issues. And just I want to touch a little bit about when is there situations where you're gonna want to use multiple PC adapters. And the only time that really is going to come to play is if you're the only time I can imagine that is if you're in a facility and you're commissioning brand new power or something like that, and you have multiple panels you want to look at, multiple 3-phase panels you want to look at, and you need more than 3 or 4 or 5 readings per panel, and you need to be in multiple panels. So you can, because part of the commissioning process is that contractor has to document all of that stuff to make sure that it's all hooked up right, it's all operating, and they have to document that for some period of time so they can put that in their report back to the customer. So
now we make it pretty easy to be able to do that.
Right. So let's touch a little bit about the safety aspect of the wireless test tools. And you know, today the way it is with conventional tools and 1 meter, I mean, if you're working in high energy panels, you're standing, because of the length of those test leads, you're standing right in front of all of that energy. And up until a year ago, when test probes could be 3/4 of an inch of metal at the probe tip along, some of the spacing in some of these 3-phase panels is fairly close from phase to phase. And so traditionally, arc faults generally occur when somebody slips in that panel or they get distracted for a moment and those test leads come together. They don't have to actually touch to create an arc flash or an arc fault. So today we supply probes that have reduced metal at the tips. The wireless tools allow you to hook up to that panel with alligator clips to whatever it is you want to measure, and should you choose, now if this panel is live, you're going to be in PPE. If this panel is not live, you can install these modules without PPE, put the panel covers back on, close it up, and then fire it up with the panel cover in place.
Okay, so shut it down, lock out, tag out.
Right, right.
Be sure it's a dead panel.
Right, and then you can energize afterwards without the use of PPE. You're going to have to, if you're talking about a live panel, you're going to have to suit up at least once to install the equipment, and then you can close the panel doors and so on and so forth. You can put the modules in logging. You can turn the radio on. Once you get everything installed and shut up, you can remove your PPE, and you can view everything without having to worry about it. The other nice thing is if you have to work on live panels and you're suited up, the slide earlier that we showed you with the technician with an arc flash hood on, as I said, it's very hard to see the meter readings through that tinted shield. So, you know, once you get this stuff installed, you can take your hood off, and then you can see everything just fine. So, and previously I wanted to mention that you know, it's not been possible to view live readings inside a panel with the doors closed. And so here's an example of what we're talking about here. The upper picture shows where you have, you know, this is more photo work, but we've got 3 clamp modules installed in there, and the technician is viewing the readings on those clamp meters while that panel door is open. Well, you can shut those panel doors now, and we can see that the clamps are simulated behind there, but now there's no PPE on, and the technician is looking at the panel meter readings right next to the panel. So it really reduces the danger that the technician is in, and it reduces the use of that unwieldy PPE in some cases. So in a nutshell, the wireless tools offer you possibilities or chances to reduce the amount of times that you need to take that PPE on and off again. So it saves time, increases safety, and it also makes it a little bit more comfortable. So let's talk a little bit about convenience and the amount of things that wireless tools can do as far as a convenience for the troubleshooter. Basically the first 2 bullets talk about separation issues when you've got to move from place to place or point to point, and that takes time. It's tiresome. And another case is if you're climbing up and down ladders. If you're working on lighting in the ceiling and you got to flip a switch on the wall or flip a circuit in a panel, you can get up the ladder once, install the gear up there, go back to the panel, flip your switch, see your readings, and you don't have to, as for those of you that do a lot of that electrical work and are constantly up and down on ladders, it's tiring, it's painful. The older guys like me can't do that forever, so it really helps.
When we're talking about the separation, let's say you hook up at some lights and a ballast and the panels in the other room, what distance are we talking?
Well, the wireless tools in the frequency that we use, which is 2.4 gigahertz, by the way, is a high frequency RF signal that's the same frequency band that's used by Wi-Fi and Bluetooth. And in our cases, line of sight unobstructed distances can be up to 20 meters, which is 66 feet. But if you're talking about going through rooms, going through windows where there's obstructions, walls, carpeting, that sort of thing, going around corners, the communication distance is going to be reduced. And even inside, if you're talking about having the modules installed in steel panels, which is a nicely enclosed steel box, you know, you're probably only going to get about 5 or 6 feet of distance there. But you know, the key thing is that you're away from the danger. That panel's closed, and that's a bonus for you. So you know, every environment is a little bit different depending upon your needs. But the key thing is you know, there may be a few cases where people need that real long distance. If you're in a an empty large factory or facility, that's one thing. But if you're in a production facility where there's a lot of stuff in there, your distances are going to be reduced. But the key thing is that it still solves separation issues for you, and that's still of huge value from a productivity standpoint.
Like you said before, it becomes an enabler, I guess.
Right.
If you had to measure inside a sealed panel, you can't really run the test leads outside a corner of the panel and still seal it.
You know, you're not going to comply with OSHA standards and things like that.
But now you can, because you're still going to be able to transmit that resultant outside that panel.
Right. So a lot of these conveniences are typically new things. The wireless concept itself is enabled users to do things a lot easier, a lot faster, and a lot safer. So let's talk about some common facility applications for wireless tools and where the wireless stuff really shines. In a case of things like load checks, and basically if you know, for instance, in a facility, if you're on a you're on a branch circuit in a facility and you need to add a new machine, a new system to that facility, you need to determine whether you have enough capacity in that circuit to add that equipment, or do you need to pull a new circuit. So to do that, conventionally, you'd have to do one current measurement at a time over 3 phases. We're assuming that in some cases this is 3-phase, or it could be single-phase for that matter for this type of thing. But you'd need to do that. With 1 meter, you're going to get 1 measurement at a time, and if you check that during the day, you're going to have to guess at what that ampacity, how that ampacity shifted or changed during the day. With the wireless stuff nowadays, and especially with the logging capability that the wireless stuff has, is you can look at that load variation over the course of a day, a shift, a couple days, or whatever, to see how that load varies, and so you can get a good reading on what's the average current load at any given time. And so then you know what your maximum ampacity is. So it helps you easily determine whether you can add load or not.
So if you're going through a distribution panel, let's say, you'd be able to see what your total amp draw is, as well as branch circuits that make up that. So in essence, you can go to individual pieces of equipment. If you see an overload, or if you see a breaker that appears hot, if you're using thermal imaging or whatever, and it clearly has a lot of current going through it, you can actually go to the consumers and try to determine which one is combining the greatest amount of current to that.
Right. Well, typically you're going to know in many cases that when you're on that panel, you can look at the maximum circuit load for the whole panel easily, and then I would hope that in most facilities that those panels and those individualized breakers would be labeled somehow, so you'd know what's on those circuits. Of course, then again, maybe if it's a real old facility, there isn't any markings and you don't have any idea. So you'd have to do some circuit tracing in that in that case, or you can use some of the wireless tools to help you do that. Here's another, we touched on that. Here's an example of doing a load check on a car wash system, which is actually 3 different motors. So you can actually look at this over a period of time. You can monitor all 3 motors at the same time. You can look at the changes during the course of a day. You can gather that information. You can identify whether, you know, the motors are running good together, or whether it's easy to see overcurrents, undercurrents, or what the nominal load should be according to the nameplate ratings.
Now I noticed on looking at it, at some of these modules, the current, you have inrush.
Right.
Can you tell me a little bit about inrush?
Inrush allows you to measure the startup current of a motor, because any time you have a motor that turns on from the off position, there is a huge spike that occurs at startup, and depending upon the type of motor and the design of that motor, that startup current will vary. And they all have, there are some industry standard inrush numbers that are associated with certain types of some motors depending upon the motor rating. So that's one way to tell a motor health in the case of startup. Also, it also gives you an idea whether your breaker ampacity is set or established properly for the startup, because if you put a motor on that's got too much startup current and a breaker that's not rated for that kind of startup, you're going to have trips that will drive you crazy.
Okay, so if you have a lot of nuisance tripping in a situation, you may be able to use that function to help you isolate.
Yeah, that's where the logging really comes into play with some of this stuff. Is that you can look at how that load changes over time, and you can find those nuisance trips. Here's another common application, depending upon how loaded your situation is current unbalance. Anytime that you get, the same with voltage unbalance, but anytime you get phases on a 3-phase system that are not close together, you're going to have problems with whatever equipment is hooked up to those particular circuits. And with today's electronic loads, like VFDs and other things, they're fairly sensitive to unbalanced conditions, where if something gets out of whack, that drive is going to trip out prematurely or not run, and you're going to wonder what the heck's going on. So
now these flexible CTs, current transformer, right? A half an amp to 2,500 amps, is that correct?
Yes.
Okay, so pretty wide range for your ability.
Well, there's 2 things going on with the flex clamps. One is you get very accurate readings. Those are essentially Rogowski coils. But you get very accurate readings from the low end to the high end. That's something that you don't normally get with a conventional current clamp that's got a rectangular jaw. The other thing that the flex clamps really do for you is, if you're talking about parallel conductors or tight spaces, in a lot of cases where you're dealing with large conductor sizes like 500 or 750 MCM, if you've got parallel conductors on phases, you can't get a conventional current clamp around those parallel phases to measure that phase ampacity. Where the flex clamps, you know, you can fish that stuff around, you know, any number of parallel conductors and get the total reading for that phase. And that is for the life of people in the electrical world that are dealing with those large conductors in those tight spaces, the flex clamp is a real gold mine.
So the conductor doesn't have to be in the center, and if you have another conductor on the outside of the loop, let's say with current going through it with magnetic fields, that's not really going to interfere, right?
Right.
Nice. Very nice.
So again, the wireless stuff helps you. In this case, when we're talking about, you know, current unbalance, we're talking about a 3-phase situation where 3 modules can help you do that. You can see everything all at one time. Typically what you do in conventional methods is you make one measurement at a time, and then you have to calculate your unbalance. Well, anybody that's used to doing this kind of thing, if you had 3 of those flex clamps or 3 of those hard jaw clamps around 3 conductors, you're going to see those 3 current readings in that display at the same time, and you're immediately going to know whether you have an issue. So it's another time saver. Voltage unbalance, very similar to current unbalance. You'll be able to see the readings very quickly. In the life of an electrical system, the voltage unbalance typically doesn't have as much leeway as current unbalance. There are rough standards for voltage unbalance. You want it 2% or less in most cases. So you want those three readings to be an average of 2% or less within each other, so you don't have any issues there. In current, typically I'll throw a number out there, and it's generally 8% or less in most cases. Otherwise, if you have more than an 8% difference, you have other things. You probably have some power quality issues you need to look for, or some other circuit systems you need to look at. But the wireless stuff and the multiple readings, the ability to make multiple measurements at once, you couldn't do this without, for instance, the screen we're looking at now with the voltage imbalance. Prior to this, you'd need a three-phase analyzer to do that measurement. And again, going back to that, that's $3,000 or $4,000 or higher for that sort of thing. Our system is fairly low cost in this case, and there's quite a cost savings for doing the same.
Now, what about the category rating for electrical safety on these?
All of our, like the voltage modules and the meter are category 4, 600 volts, category 3, 1,000 in most cases. So they've got the highest safety ratings that we use in most of our products. So good for working indoors on from the service entrance onward, and also you can make the category 4, 600 volts allows you to measure power, utility power, or line power outside, like at the meter, or
up to what voltage on these?
Up to 600 volts. It depends on whether you're indoors or outdoors. Outdoors up to 600 volts, indoors up to 1,000, depending upon where you are in the distribution system. So, and in the case if you're talking about underground transformers, you're talking about electrical power that's been run over to an external facility, stuff like that. That's where the Cat 4 600 volt rating comes into play, especially if you need to do line power type measurements. Again, this is power interruptions, about circuit intermittence or things where you've got to see multiple things happen at the same time. The wireless tools again offer the convenience of being able to see multiple readings at once, where you can turn loads on and off. You can see whether when turning on a load at one point affects the loads at the other 2 points, and see if there's any power interruptions or unexpected situations that pop up. So the ability to see more allows you to make quicker decisions. Here's a typical conveyor system where the motors may be located at different ends of the conveyor, and the control is in a different place. So again, you've got serious separation issues here if you want to see what's happening when a certain part of this process is taking place.
So this can be an example where that's the mid shift and they have resets in the middle of the night.
Yeah. So you need to actually look at both ends of the spectrum when you start your process. If you don't know what's going on, the more you can see, the quicker, the faster you can make a decision as to where the problem might be.
So this will keep really uptime.
Yes, it's all about uptime. I mean, it's really all about, when you're in a production environment, time is money. If that environment or that production process isn't running, you're losing money every day or every hour, whatever the case may be. So again, we go back to touch on single phase and multi-phase measurements. You can see one reading, you can see three readings, and you can be at the load, you can be at the panel, you can be at the contactor, wherever you need to be. You can typically be there and then see what's going on. It's a real convenience. Again, this is just a summary kind of conventional versus wireless. Conventional methods, one measurement at a time, and you may need to be in 2 places at once, which is reduces your productivity, increases your cost because you have to have a helper. You may need to write the readings down that you're seeing and then build those into a report. Multiple measurements on a 3-phase system may require you to have a 3-phase analyzer, which is expensive and it's not as prevalent as individual tools. And you may not be there when whatever it is happening happens. So wireless addresses each one of those things by helps increase your productivity and reduce your cost by seeing multiple readings. At the same time, it allows you to analyze things faster, quicker decisions. It also allows you to record information over an extended period of time. It improves safety by not being in front of those.
So really, your imagination is almost your only limitation. The reason I ask this is I had a gentleman I talked to recently, and HVAC, right, had to measure some pressures. Even though you don't have a pressure module, you have the DMM that's capable of having an accessory plugged in. So you could take one of the pressure modules, let's say, and still measure the resultant of pressure and get that as a remote reading.
Yes, yeah, because our particular system allows the multimeter to be turned into a module, so you can use other accessories or situations to help you. Because everybody's situation is a little bit different, and everybody's environment is different. So, but the advantage of the wireless technology is it allows you to think outside of the box, and allows you to adapt that wireless capability to whatever your environment is. And believe me, from people that have made their own test leads, used multiple meters 3 or 4 times to capture situations and stuff like that, or really gotten creative with the conventional methods. The wireless method's going to allow them to continue to think outside of the box and make use of that new technology.
This really becomes an enabler.
Absolutely, absolutely.
I think we've hit on most of these as the review of benefits, which increases productivity, safety, and travel time and moving around.
Yeah, absolutely.
Well, Paul, I think we've come to the other end of the tunnel, and we're just in time. If there's some questions.
Yep, we have a few questions. First of all, is the wireless protocol proprietary to Fluke, or is it industry standard that allows the connection of devices from multiple manufacturers?
Right now it's proprietary to Fluke. I mean, we're on the same frequency spectrum as Bluetooth and Wi-Fi, but our particular product uses a Zigbee physical layer with Fluke protocol, and so it is proprietary at this point in time. But you know, we'll see how it goes. I mean, we've had interest in folks embedding this stuff into their systems. So, I mean,
Yeah, this has been on the design table and in engineering for some time, and part of it is to ensure that when you're getting a reading on the meter or no reading at all, that either there is voltage or there isn't. So in other words, if you're reading 0, there has to be 0 voltage on the other end of this.
Yeah, so, I mean, so right now it is proprietary, but it's one of those things where we're more concerned about user safety than anything else. So, you know, time will tell.
Okay. A couple more questions. Can you confirm, I believe you said that the 20 is the max number of devices that you can have per system. Is that correct?
Yes. Yeah. Okay. Now, each PC adapter or each system can communicate with 10 modules, and you can have two adapters in our system.
Yeah, and let me also add to that, because the question comes up, for instance, let's say it's a a refrigerated area, or let's say you're around a hotel and you need to monitor the HVAC system in numerous locations, and it might be more locations than you have not only separation distance, but maybe there's more than 20 locations. That doesn't keep you from getting multiple, over 20 temperature modules, but then you can synchronize those back in from the logging and take those into the computer when you get within range.
Okay. And then I think we have time for one more question. What is the typical battery life on the modules? How often do they need to go in and access the actual modules that are behind closed door?
The runtime on the module batteries is 400 hours. It gives you roughly, without, and I mentioned earlier in the session, it's 400 hours, so it gives you about 3 weeks of runtime without using the radio. If you have the radio on and you're logging at the same time, if you want to communicate that way, you've got about, that 400 hours will give you about 8 days.
Yeah, it's probably very similar to our cell phones that we use. If you turn on Bluetooth and turn on the backlight all the time, and you can see consumption go up greatly. But if it's monitoring on its own and sitting there recording without wireless communication, it extends some of the battery life.
Paul, one comment to that. I mean, these particular tools in this system is really designed for troubleshooting purposes. Mm-hmm. It's not a what you'd call a permanent install monitoring system, you know, where you'd embed these modules for forever in a situation like that. So this is more for troubleshooting or really short-term monitoring. You know, as I mentioned earlier, if you talk about load studies, a load study by NEC code has to occur over a 30-day period, and but still you can get a lot of information out of logging for a week or 2 weeks or even 3 weeks, and so you can still do a lot of what you want to do to get the answers you need. You just, you know, there are limitations, and we realize that. But and these are, again, these are designed for troubleshooters and short-term logging scenarios.
Yeah, and the other nice part, these use standard AA batteries. Yeah. So you don't worry about any specialty battery or recharging over time. If you need some batteries, you're out in the field, you're remote, stop by the tool crib, you just put in some more batteries, you're good to go.
Okay. All right. Well, thank you very much, Dwayne and Corey, for your time this afternoon. That does conclude our time today. You will be receiving a follow-up email with the slides and a link to the recorded webinar. If you do have further questions or would like to find out more about what was talked about today, please contact us at 800-828-1470 or on the web at transcat.com. We want to thank you very much for joining us today. We hope that you found this very informative and useful and applicable to your jobs, and we hope you have a good rest of your week.
Thank you.
Thank you, Paul, and thanks to everybody that attended.
Yeah, thanks, Transcat. We appreciate it.